Before doing a linear regression, variable has to be quantitative. Scatterplot must be linear. And outliers give the correlation with and without outliers. I'm just trying to get it to focus in. You don't need all these random lines drawn. There we go. Oh, oops. Okay. Roller coasters get all their speed by dropping down a steep initial incline. Well, not all of them, but a lot of them do. So it makes sense that the height of that drop might be related to the speed of the coaster. Here's a scatter plot for the top speed and largest drop for 75 roller coasters around the world. So notice we've got the drop height here, speed is here. And so we can see, kind of what's happening. Does the scatter plot indicate that it is appropriate to calculate the correlation? So are both of these variables quantitative? Yes, so both variables quantitative. Does it look linear? Say relatively linear. What about outliers?
It feels like there's a couple that could be like the ones that
Like those two?
like 80. Yeah, those two.
Yeah. There could be. It's hard to say. It's close enough that it's probably not, but there could be. So I would just say something like probably no outliers, just because it's hard because we can't actually calculate it. Usually if they're going to have outliers, if they don't explicitly tell you, it's going to be something like this. Like it's going to be like way off like the beaten path. But, I could also see your argument that those two right there maybe could be, they're a little farther up than the others, but I think if we actually calculated it, they probably wouldn't be.
So even if, does number 3 mean that like even if there are outliers that there still can be a correlation?
So basically, if we know there's an outlier, then we're going to give the correlation as it sits with the data exactly as it is, and then what I would do is I would go remove that piece of data that's an outlier and then rerun it and see what happens, because it can drastically change your correlation with an outlier.
Okay.
So all that stuff is met, so conditions met. Calculate correlation. Or I guess I should say we can calculate.
I thought you were telling us to. I was like, I don't know.
No. Well, it's actually in the next part of the next question.
Well.
In fact, the correlation of speed and drop is 0.91. So let's describe the association. So R is approximately 0.91. How would we describe this? Like strong, weak, moderate, positive, whatever. How would we explain it?
Positive, linear.
Yep, strong, positive, linear relationship between initial drop and speed of the coaster. And so specifically in the context of this problem, coasters with a larger initial drop tend to have faster speed. Huh?
Another one of cell phones and life expectancy.
It's the exact same question. It's accidentally typed twice, yeah.
I was about to say, can't live through that again.
All right, our next one is drug use. Told you, it's a common topic in here. A survey was conducted in the United States and 10 countries of Western Europe to determine the percentage of teenagers who had used marijuana and other drugs. The results are summarized in the table. So we have the different countries that are listed there. We have the percent who have used marijuana, and then that have used other drugs. So what you're going to do is this use marijuana is going to be L1. Other drugs is going to be L2. So notice, because there's, instead of doing one long table, I have it split into like two, like little individual ones. So put all the stuff that's marijuana in L1 and then everything that's other in L2.
Oh wait, everything, so we put both L1s together and
Yeah.
L1? Okay.
I just did like two short tables instead of one long table.
Got it.
I don't remember having so much in my L1.
Did somebody borrow your calculator?
Probably.
Although the Algebra 2 stat plots that they were doing don't have that many numbers. The biggest one I think had 9 numbers.
It was probably from when we did that one thing in stats where we had like, when we were doing like finding or doing the box plots and we had that.
Oh yeah, the test had a lot. One problem that had a lot on it, if I remember correctly.
That's probably what it was.
All right, so we're going to create a scatter plot of the data. So basically, you're just copying it as it is off of your calculator. But the X list is the percent that I've used marijuana. The Y list is the percent use of other drugs. Have we done drawing scatter plots in here? I don't remember.
Isn't it, you just go to the same spot you usually would, right? And just,
I don't know if we
I
did.
don't remember if we did or not, so I'm going to put it up to walk through it just in case. Just to make sure. Alright, so do we have our L1 and L2 done? Alright, so what we're going to do is hit second quit. Really fast, just to check something to make sure that everyone's calculator is in the same thing. When you hit the mode button, arrow up until you get to the one that says stat diagnostic. Make sure it's on. I want to say we had turned it on previously, but I just want to verify. Hit mode, arrow up until you see stat diagnostic, and make sure that it's on. Because if not, we won't be able to finish this problem. So.
Do we just always keep that on? So okay.
And then I can quit to get out of that. So to do the stat plot, we hit second and then y equals, which brings up stat plot. So we've done other stuff with this. Make sure only plot 1 is on, or that only one of the plots is on. It doesn't really matter which one. So turn it on if it's not on. This first option that's like the dots randomly on here, that's your scatter plot option. So select that one if it's not already selected. X list should be L1, Y list should be L2. Do we have that? And then you're gonna hit zoom.
How do you make it L1? You just.
Oh, you can't hit that where I'm currently at. Ah. What do you need? You need L1.
Yeah, I need to change it to L1.
Hit second stat, and it brings up the list names, and then you just pick which one you want.
Okay. Okay. Alright, now I'm good.
Alright, and then hit zoom. And then 9, which is zoom stat. So I've got so something like that. So just try to draw it as close to what it looks like on your calculator as possible.
Mine's not showing up, but I don't know why.
Did you hit zoom 9?
Yeah.
Is your plot on?
Alright, hold on a second. I'll look and see.
So all that's good.
Hit zoom 9.
How many pages are you reading, Josh?
That means your lists don't have the same amount of numbers in them. Did you type something in wrong?
Pages are in the beginning, like 20, and then,
I know, it's all more, right?
yep.
I think it's night. Ooh, I forgot.
Oh, it's because the other two numbers that were in the list already were still there.
You have to make sure that they're lined up correctly.
Yeah.
And then you don't have to go through the whole process again. You can just hit zoom 9 and it will automatically do it
Okay.
since everything's already set correctly.
You can keep going if you want. I just gotta type the numbers in.
That's fine. I'm just writing down what the next thing is that we're looking for.
Okay.
So next thing is what is the correlation between the percent of teens that have used marijuana and the percent that have used other drugs? So basically we just want to see like, you know, kind of like is there a relation between marijuana use and other drugs? And so this correlation coefficient is going to tell us that. So we do second quit to get out of your graph. We would hit the stat button. That's what I've written here. So stat, arrow over to calc. Option 4 is len reg. It says ax plus b, so that's going to give you the equation of the line. So option 4. X list should be set at L1, Y list should be set at L2. Frequency list has nothing in it. That just is left blank. Then we have this store reg EQ right here. So that means store that regression equation, which is the equation of our best fitting line, which we're not really doing anything with that in this section, but it will come up. I want to say it's chapter 8, I think. But anyways, I'm going to go ahead and show you how to do that just so that you have the like heads up. So what we do is we hit alpha, trace, and it brings up all your different y equals. So I'm going to put it in y1.
Is it alpha trace?
Yeah, alpha and then this trace button at the top.
Okay.
And then arrow down to calculate. And it'll run it for you. And so the equation of our line would be y equals 0.54x, well, I was going to say plus, but negative minus 2.37. Now you're going to notice that down here we have a r squared and an r value. We need the r squared value. And it's not the number that I have on my paper, but
Mine's a little different.
what is yours?
0.8725.
Here, hold on, let me go check my list to make sure I typed everything in right. Oh, wait. Okay, that number was wrong. Let's see. Oh. Okay, that means my graph's a little off. This point. Actually over here. Oops, wrong color. That point's actually like right there. Okay. Then let me go back and rerun this now because I had a number wrong.
Wait, so do we use alpha trace before that or after we already have all the one variable stats?
We didn't do anything with one variable stats on this problem.
Well, like the calc thing, the thing that was like
Stat, calc, len, reg, you typed it in up here. We did len, reg. Okay, this was the number I was expecting to see. Your R value's 0.8 something?
No, I thought you were talking about r squared.
Oh, I was like, something's really off. Okay.
No, but
Yeah,
that's
no.
what I have.
R value, yes. So R equals 0.93. So that's what we're looking for. So, point proven why it's always good to check your list and make sure you typed everything in correctly.
You meant to do that.
Huh?
You meant to do that.
Yeah. Just wanted to prove a point. All right. Write a brief description of the association. So I would say this is a strong positive linear association between marijuana and other drug use. And from that, what I would say specifically for this problem is that countries with higher percent marijuana use also have, or also, let me say, tend to have higher percent of drug use. So to follow that up, part D, I don't know why mine doesn't say part D, but anyways. Do these results confirm that marijuana is a gateway drug, meaning that marijuana use leads to the use of other drugs? What do you think?
Is it one of those where it's like one's not really causing the other, it's just kind of like they both tend to just because one's happening doesn't mean it's the cause of what the other one is.
Yep. So, first and foremost, no, correlation does not equal causation. We can't prove using marijuana leads to using other drugs. Because all this tells us is that the amount of people that have used marijuana and the amount of people that have used drugs, it doesn't say it's the same people. It doesn't say that of these people that have used marijuana, these have also used other drugs. We don't even know, for that matter, that they didn't start with other drugs and end up on marijuana. So that's why correlation doesn't equal causation. But we can see that the tendency is that countries with higher use of marijuana also have a higher use of other drugs as well.
Can we ever prove causation if it's like super tied together? Or is it always just going to
It's
be...
not going to ever prove causation.
Okay. So
It's just
always
going to show it's a stronger correlation. But there are some things, I mean, that you might be able to, but not in the stuff that we're doing right now.
Got it. So are we always going to use like the correlation is not equal causation thing? And
Pretty much.
okay.
Finally, I got it.
You did it? You want to try to get this other one?
The reaction was so like mild for how long you've been trying to do that.
Oh, I finally got it.
Oh, fun.
You want to do this one?
I guess I could re-cube it at least. Let me just mess it up. It'll turn back eventually.
What if you never can get it back?
All right, I think we'll finish this page and we'll have one left to do tomorrow.
What time is it? I just realized I've been looking at I was thinking like we have like 30 seconds left. What are we doing?
It's 11:27. I think next period I'm going to go try to get a battery from the office.
Because I was like, wait, we're starting something new? Like, shouldn't the bell have already rung by now? But then I realized the hour was off, so I was like,
Yeah, I know. I keep looking up there too. It's why it's throwing me off because it's actually ticking.
yeah.
The other day it had stopped ticking and all of a sudden it started again, but it's off. Like the time's wrong. So
Oh, well.
yeah, it's fine. And it doesn't like hold time whatsoever because it's not off by the same amount every time. All right. Owners of a coffee shop track sales for the first 20 days and display it in a scatter plot by day. Make a histogram of the daily sales since the shop has been in business. So essentially we're just redrawing this data in a different form for this first step. So a couple things to notice here. Each day has one dot, right? Because they only have one set of sales each day. Like in total, like your total sales, you don't have multiple totals for one day. So first day it's 300, day 2 is 100, day 3 is 200, day 4 is 300, so on and so forth, right? You can follow it along that way. So Scatterplot looks a little different than some of our other scatter plots. Now notice, they've already totaled these for you. If you had this problem on like a quiz or a test, you wouldn't have these totals already out here. You would need to add up, how many days did they make $500? How many days did they make 400, 300, 200, 100, so on and so forth. So what I'm going to do is I'm going to actually make sales my X value. So I'm not just taking this and just being like, all right, here's a histogram, boom, done. What I'm doing is I'm actually looking at the sales since the shop has been in business. So for the first 20 days, I'm going to set it up. And so my histogram is going to be, I'm going to have 100, 200, 300, 400, and 500. And these are sales in dollars, obviously. Now, the left side's actually going to be frequency, how often it occurs. So we have to remember that about histograms. So frequency is over here. So since the most frequent is 8, I'm just going to go up to 8, and I'm going to do increments of 2. So 2, 4, 6, and 8, since that's all, these are even numbers. And then I'm just going to draw my histogram for this. So how many days did we have? $100. There were 2, so I'm going to create between the 100 and 200 marker like that. That's my first box. Then $200 was 4 times. $300 was 8 times. Oh, this is bad. I didn't leave enough room. Hold on, I want to see something. Can I?
I never knew you could do that.
Like, do what?
Delete as. Like she picked it all up and moved it over.
What? Can you do it again?
Steve Jobs, I'm proud of you. How long ago did he die?
I think it wasn't like that. Did he? When did he die?
Is the last one just supposed to be going like from 500 to?
I don't think I can.
That is so
this
cool.
right now.
I wish I could do that on like my paper.
I need to go out to 600 because of the way that I've drawn this.
You know how much that would suck though if you could like do that on your paper and then you get used to it and you get like an old paper and you can't do it on it.
Like,
I tried
Okay,
to zoom in
there we
on
go.
a real
Oh,
life
I just
picture.
realized I turned all of this. I turned all of it black. Hold on.
you took the life out of it.
Hold on. I didn't even know I could do some of this.
I like how you made the sails like alternating colors.
That was not on purpose. It just happened. Okay, there we go.
Perfect.
Okay, well, we probably won't get through this problem now because I failed at drawing. Anyways, $400 was 4 times. And $500 was 2 times.
It's beautiful.
Yes.
I'll try to
So-
fix that later.
You already said that, so I'll go ahead and put this down here. The fact that's, well, hold on. We'll go back. State one fact that's obvious from the scatter plot, but not the histogram. Basically, if we look each day, right, we started out with pretty low amounts of money early on, but as we get farther along in our days, our sales are increasing, right, to the point that after day what is that, like 14 or something, all of our sales are up here $400 or $500. So we can see that the trend is that sales are increasing over time. I'll go ahead and wrap up C really fast. It's quick. State one fact that's obvious from the histogram, but not the scatter plot. So you already said, you know, it's symmetrical. And it's unimodal. Then we can also say, I mean, we could kind of see this in the scatter plot, sort of, but it's clearer here than it is in the other thing. The most frequent amount of sales is $300, and it happened 8 times. So we'll finish up the last 2 tomorrow, and then you'll have the rest of the time to work on your problems. We'll start chapter 8 on Monday. Most likely, we will be ready for a quiz the following Monday or Tuesday.
Oh, wait, so not next week, but the week after?
Right, yeah. Because it'll be on chapter 7 and 8, so it'll just depend on how fast we get through stuff. But chapter 8 will probably take an extra day or so compared to this one, so we'll just see where we're at.
Are we on schedule right now? Are we ahead of it, behind it? Like, where are we right now?
Pretty on par, I would say.